Okay, let's have a look at this question now. We're given Z2 and Z3 and we want to figure out what Z1 is. Okay, so 2 over Z1 equals 1 over Z2, which is 2 plus 3i, plus 1 over Z3, which is 3 minus 2i. Let's combine these fractions into one. So we multiplied the denominators. 2 times 3 is 6, and then 2 times minus 2i minus 4i, plus 9i minus 6i squared. Then we do the cross. 3 minus 2i plus 2 plus 3i. So on the top we have 5 plus I, and then on the bottom we have 6 plus 6 is 12 plus 5i. Okay, so that's 2 over Z1. Calculate the reciprocal of both sides, so I get Z1 over 2 equals 12 plus 5i over 5 plus I. And then I'll multiply the top and the bottom by the conjugate of the bottom. So on the top I have 12 times 5, which is 60, minus 12i plus 25i minus 5i squared, all over 25 plus 1, so 26, then the denominator. So let's see, that's equal to 65 plus 13i over 26. That's Z1 over 2. I'll multiply both sides by 2, so that becomes a 13. And 13 goes into 65 5 times, doesn't it? So if I divide everything by the 13 here, I get 5 plus I. Okay, part B now. Omega power n is 1. Calculate S using the GP formula. So S equals A, the first term, which is 1, times 1 minus R, and here clearly R is omega. 1 minus omega n. The formula I'm using is A times 1 minus Rn over 1 minus R. That's over 1 minus omega. But omega n is 1. So it's actually just going to be 0. And there's a reason for that. I think it's kind of a Argand diagram reason. So let's say you have omega cubed, for example, equals 1. So the 3 points on the diagram would look like that. If you add them all up, you'll get to 0, because all the reals and imaginaries will cancel. So you can kind of see it more clearly with a small number like 2. If omega squared is 1, then that means omega is plus or minus 1. So clearly when you add those 2 points together, you get 0. So there's a kind of a geometrical thing going on here, as well as the reason for getting 0. Yep. However, you might just want to make sure that the omega is not 1. And it's not, because they say it in the question. So we're good.